Hello guys, welcome back to another episode of Talks Writers. In this video, we want to talk about Python package managers and Conda environments. Okay, I said Python package managers, and by that I mean PIP. Yeah, Pip or PIP is the most famous Python package managers that is primarily used to install Python libraries and Python modules, but there are lots of programs that are released in a way that their binaries can be installed using PIP, very similar to APT. So as an example in this regard, I want to show you one of the mesh manipulators that I use a lot called meshio, and in future videos you will see that I will use it, but the way that you can install it is as simple as using PIP. So meshio can be used in two ways, two different approaches. One is to be called in as an API in your Python programs, and another way is by calling its binaries. There are several binaries released by the developers of this module, and you can directly run them from command line. And as a result, you can see that you can use PIP to install binaries. Yeah, why not? But before going to that, let me show you how what this meshio is all about. So this is indeed a mesh manipulator that is mainly used to convert mesh files from one format to one another, but also to generate mesh and finite element grids. So this is indeed a library, and we want to install it. So let's see if we have PIP installed. I think it got installed alongside the previous programs that we installed, and we have to just call and run this command. But because sometimes you will have some problems with that. So I call pip3 because in Ubuntu, in this version of Ubuntu 18.04, there are two versions of Python installed, Python 2.7 and Python 3.6. So when I say pip3, I mean that please install the version for Python 3. I am not sure if pip3 is installed or not. As you can see, it says that please run and install this Python 3 PIP. So we have to run this and a password, and it says this requires installing all these Python dependencies that indeed we also required for later videos. So let's install them. Yeah, why not? We needed to install some of the dependencies we need for development videos, for the videos that I want to show you how to compile things, and by this command they are automatically installed. Let's wait for it to finish. These GCC things, I needed them for next videos, but now they are all installed. Not bad. And then after this finishes, it was all for installing this Python 3 development. And and now we can go for pip3 install and meshio. Let's install it. You see that it collects also some of the dependencies. So you can see that, for example, as an example in this regard, meshio depends on numpy, and numpy is not installed, so this pip automatically takes care of those dependencies. And then after this, meshio library is available. So if I go to Python 3 and import meshio, you can see that it doesn't complain about lack of the library. It says module not available. But as I said, what I wanted to show you was indeed related to the binaries. So you can see that I have a couple of binaries here. Apparently I don't have. Yoo-hoo. Let me run that again. I found a reason. There is a very nice reason behind this. Let me show you. The fact is, when you install something using PIP, it goes to a directory in a .local folder. You can see the folder here is a hidden one. That's why I used this A switch. Now I can see it in my home directory. When you install something using PIP, it goes there. So I go there. You can see that we have a couple of directories, and it's usually inside bin. Executable are always in bin. This is a kind of rule of thumb in Linux. And you can see I was looking for these binaries, as was also here in this documentation. These binaries, these utilities are installed alongside meshio. But this directory is not part of my path, as I described in the previous video. So let me show you my path environmental variable, path variable, and you can see that it's not here. The reason, let me go back to the parent directory with this tilde. It says go back to the parent directory, to the home folder. And here again, I have a couple of let's say scripts that are run every time a new bash session is initialized, or every time you log into your profile. One of these that we used in previous video was bashrc. But there is another one called profile that is executed every time you log into your profile. For example, I log into my desktop session, or you log into your text session from the login page. Let's have a look at this profile profile script, let's say. As you can see here, it says that, for example, if the home bin exists, then add that to the path. And here, this one also says that if home local bin exists, add that to the path. But as I said, this is executed every time that you log into the system. And as I have installed PIP recently in the current session, in my current login session, this script is not executed. And as a result, I have to execute it. Source profile. And when I run it, then I have access to these binaries, because the path of that local bin is added to my path variable. So as you can see, now I have access to this meshio utilities, and yeah, I can easily run them. So this is indeed a way that I have installed something using using PIP. And using PIP, you can easily do this kind of installation, especially the ones that are related to Python. But yeah, there are also other rare cases in which people use PIP for other programs written in other programming languages. But yeah, this is indeed a very simple way to install programs. But this sort of usage of PIP brings an important problem. Maybe you can see that. The problem is, imagine that you work on various projects, multiple projects at the same time. And you want to, let's say, install different libraries or programs for different projects. So in one project, for example, you're working on a web application and you want those kind of web dependencies, and in another one, you're working on a scientific computing application, all using Python. And you want to install those kind of dependencies, and then these dependencies can conflict. So one of the best practices when you work with Python, with these kind of ecosystems, is taking advantage of virtual environments. With virtual environments, you can easily, let's say, create an environment, as the name implies, and then when you activate the environment, you go inside, and then you can easily install, different dependencies. And when you deactivate the environment, then all of them are deactivated from the users, from the system, let's say. So it's a sort of encapsulation. And for our case, when we will start to use Python for our scientific computing development, we will create separate virtual environments for each project. And this is indeed a very good practice. Python provides different approaches for virtual environments, but one of the best ones that I also recommend you to use is Conda. Let me show you what Conda is. So Conda is indeed, let's say, a virtual environment manager that can also be used to install various dependencies, various Python modules. So this is indeed a comprehensive web page for managing various virtual environments in using Conda. You can see that there are lots of commands, but before that, we need to install Conda. In order to install Conda, one of the common way is taking advantage of Anaconda distribution of Python. And yeah, when I say a distribution, the concept is very similar to Linux distribution. So in Python programming, there are a large number of different libraries, packages, and this kind of distributions, there are a couple of them, this kind of distribution make life easier for developers. So they bring, they pack, let's say, a wide range of different libraries and modules into one installation file. And then when you install it, you have Conda package manager as well as all those libraries offline. So you can go for this. It has also some cloud-based services. But if you are an advanced user or you have some, limitations in your storage, so you don't want to install all this Anaconda package all at once because it utilizes almost 4 gigabytes of disk, 3 gigabytes, 4 gigabytes, you can go for Miniconda. This is something that I always use, Miniconda. This is pretty recommended, let's say, that it installs just the core Conda package manager, and using the Conda package manager, you can easily install whatever you like. So let's go for installing that. We want to go for the Linux installers. You can see it's just 60 megabytes. And Miniconda 3, yeah, with the very latest version of Python, that's okay. Let's install this. Because at the time that you create, you create your environments, you can also choose the version of Python you want to use. It's downloaded in my download folder here. So it is indeed a script that I have to run. So I go to download. I have it here, so I have to run Miniconda. It doesn't have, okay, this is indeed very nice. Can be a nice topic. As you can see, when I list the commands, list the content of the directory, I can see that this downloaded script doesn't have execute attribute. So it means that the system cannot run it because the system doesn't trust it. It is something downloaded from the internet, and in order to run it, I have to explicitly add the execution attribute to that. This is one of the commands that I showed you in the video of Linux commands, and I said that we will take advantage of this in the future, and this is indeed one of the cases that we need it. So I add the execution attribute to that. You can see that now it has X here. So previously it didn't have that. So it didn't have the execute attribute to be run by the system. And now when I list the content, you can see that color is also changed. So I go to run it, and when I press tab, it automatically completes the command for me. The previous time it didn't, because it didn't know. It knew that this command cannot run. It doesn't have the appropriate attribute. So I press enter. It says that welcome to Miniconda. Press enter to go on. This is a sort of license agreement. I press Q to exit it. Then it says, do you accept? And I say yes. Miniconda will be installed. Press Control, and I want to be installed in a default path. So I'm totally okay with that. I press enter, and then it starts to work. It will be quite fast because it doesn't need to install lots of things. And it says that you want to initialize Miniconda. Yes, it always goes to this. Yeah. So now the Conda installation is finished. If I rerun a new bash session, you can see that there is a new thing added here called base, and base is the base virtual environment for Conda. Very similar to the way that we install things using PIP. It was installed to the system and not virtual environments. Here, the basic or the system virtual environment is called base, and it means everything you install goes to that, will be installed on that. But if you want to create your own environments, go ahead and create ones. This is a sort of precaution that for you to know that where you are. And with now we can come back to this. We have Conda installed, and now we can create our own virtual environments. You can see that the command for that is Conda create, and then we can specify the name using this double dash name or single dash name with the name of the environment and also the Python version. This is indeed what I said, as you can create whatever version of Python you want for your virtual environments. So I say Conda create. I can say test. This is in the test virtual environment, and Python is it can be 3.9. That was indeed the default, or it can say 3.8, whatever. Oops, oh sorry, it should be something like this. The name is indeed test. So it starts to collect the packages, and as you can see, that the Python is also here, and Python 3.8, and also the rest of the packages are required. So it starts to install things and installs also PIP. So I can use PIP to install libraries, or alternatively, I can use Conda to install things. So it will be Conda install something. This is not for for installing, but as you can see, you just skip this part and you can see Conda install SciPy. That is a Python package for scientific computing, like signal processing, linear algebra, this kind of stuff. And when it's done, we can activate our environment with Conda activate. It says here that you want to use your new Conda environment, you have to type Conda activate test. And when we run it, you can see that now we are inside the test virtual environment. So just imagine that we want to install Jupyter inside this test environment. Jupyter is, it's quite famous in Python programming and also other programming languages and open source programming paradigms that provides an interactive environment to run commands, programs, beside, especially in Jupyter notebooks, beside their the code, beside their the description of the code. So we want to install Jupyter. Let's see if we can install it using Conda. Install Conda. Conda install Jupyter. Let's see if it can run it. It can find it. Lots of dependencies. Always check what it wants to install. And yeah, seems that it wants to install Jupyter version 1. So we can say yes. And if it couldn't find it, then there are also a concept called channel, which is very similar to repository in apt package manager. You can ask it to look into other channels to install programs or dependencies. And yeah, you can specify channel with the switch C to the Conda install. So we have to wait. And now it's installed. So for example, you can see that inside this, these packages are installed. And when I go, now let's check if Jupyter is installed. I can say Jupyter notebooks or notebook. Yeah. So this is indeed the interface for Jupyter notebooks. And if I had some notebooks here, I could run them. But I don't have any notebook here, so it was indeed just for demonstration purposes. And very similar to this, indeed this is the best way to install Jupyter. You have now Jupyter installed with all the dependencies and it's fully functional. But I press Ctrl+C to the server. I want to shut down a server, Jupyter server. But yeah, I wanted to show you that this is indeed a way that you can install Python packages and Python programs. So very similar to PIP, you can use Conda install. Like just imagine that we want to install NumPy. I can say Conda install NumPy. And then it starts to install NumPy, and then you have access to NumPy install the Python Python interpreter that you installed inside this virtual environment. And when I'm done with this, I can say Conda deactivate, and then I go back to this base virtual environment, and here you will see that I don't have access to Jupyter Notebook anymore because Jupyter is not installed in base. Jupyter is installed only in the test environment. And I think there was a command info ins environments, and it tells me that there are these two environments created on the system, and you can activate them, go inside them, and then install programs and use Python interpreter. And when you switch the project, you can go to another virtual environment. So make sure to also read this documentation for managing environments. You can clone environments, you can copy them, you can save some specials, change some of the configurations, and delete removing them and these sort of operations. So I think it became a relatively long video, but these are indeed the things that were indeed essential to know for Python programming. I hope you enjoy that. Try to reproduce these results in your virtual environment, into your virtual machine, and then for the next videos we are ready to go to compile programs. So have fun and see you later. Bye.